The Klamath people of southern Oregon told a story. It was told out loud, parent to child, around fires, for longer than anyone could count. In the story, there are two spirits. One belongs to the world above, one belongs to the world below, and he lives inside a great mountain. They fight. The mountain spirit stands on his peak and hurls fire into the sky. The world goes dark. Burning rock falls on the forests. And in the end, the mountain itself is destroyed, collapsing down on top of its own master. And the hole that is left fills slowly with water, until it becomes a lake of impossible blue that people are afterward forbidden to look at without preparation. For most of the 19th and 20th centuries, white settlers and scholars filed that story where they filed all such stories. Myth, folklore, a colorful explanation invented after the fact, by people looking at a strange lake and imagining how it got there. Then geologists dated the eruption, and the answer came back. Roughly 7,700 years ago. Sit with that number, 7,700 years. That is somewhere around 300 generations of human beings, passing a story from mouth to mouth, with no writing, no records, nothing but memory and repetition. And the story describes, in order, a mountain throwing fire, a sky going dark, burning material falling, and then the summit collapsing inward rather than blowing off sideways, which is exactly, geologically, what happened. Then it describes water filling the hole over a long time, which is also exactly what happened. And we know people were standing there to see it, because we have found their sandals buried under the ash. This is Mount Mazama, a mountain that erased itself, and the lake sitting in the hole it left behind is the deepest lake in the United States. This is the story of the largest volcanic eruption in the Cascades in the last 10,000 years, the people who watched it, and the fact that the volcano is not finished. Let us start with the sandals, because they turn this from a nice story into evidence. In the high desert of central Oregon, there is a cave in an old rock formation called Fort Rock. In the late 1930s, an archaeologist excavating that cave found something remarkable. Sandals, dozens of them, woven from sagebrush bark, twisted and braided into footwear, flattened by time, and they were sitting in a layer of soil underneath a thick layer of volcanic ash. That ash layer is the key, because the ash that fell on central Oregon 7,700 years ago has a chemical fingerprint. Every volcano produces glass shards with its own particular recipe of elements, and Mazama's recipe is distinctive. Volcanologists can identify it precisely, anywhere they find it, and they call it the Mazama ash. It is one of the most useful single layers in North American archaeology, a continent-wide bookmark stamped into the ground on one specific date. Dig anywhere across a huge swathe of the West and hit that pale layer, and you instantly know that everything below it is older than 7,700 years and everything above it is younger. Archaeologists have built entire regional chronologies on it. A single afternoon in Oregon gave science a horizontal line drawn across half a continent, and it is still the most reliable date marker many of them have. So the sandals were made, worn, and left in that cave before the eruption. Radiocarbon dating put the oldest of them somewhere around 9 to 10,000 years old, which means human beings were living in that landscape, walking those trails in woven sandals, for thousands of years before Mount Mazama destroyed itself. They were not passing through. They were home. And when the mountain went, they were close enough to watch. Now, what did they actually watch? Mount Mazama was not a small volcano. Before the eruption, it stood something like 12,000 feet high, a broad cluster of overlapping volcanic peaks capped with glaciers. One of the great mountains of the Cascade Range, visible for 100 miles. Underneath it, over thousands of years, a chamber of magma had been filling and evolving. The eruption, when it came, did not begin as the catastrophe. It began as a single tall column. Magma reached the surface at a vent on the northeast side and blasted upward into a plume that stood tens of thousands of feet in the air, raining pumice and ash downwind for hours. That phase alone would be one of the more significant eruptions in American history. Then the mountain moved to the main event. The eruption widened. Rings of vents opened around the summit area. And instead of one column, the volcano began pouring out enormous flows of superheated gas and pumice that raced down every valley around it. Pyroclastic flows, filling canyons dozens of feet deep and traveling tens of miles from the mountain. The magma chamber was being emptied at a rate the mountain above it could not survive. And it did not survive. With the chamber drained, there was nothing holding up the summit, so the mountain fell into itself, roughly a mile of vertical mountain, collapsing inward, producing a bowl about 5 miles across and 6 miles wide. The peak did not explode away. It went down. Think about what that looked like from a distance, because people were watching. A mountain that had been the fixed point on their horizon for every day of every life anyone had ever lived there. The thing you navigated by, the thing that marked the seasons with its snow, simply stopped being there, not damaged, not smoking. Gone. Where a 12,000-foot peak had stood at dawn. By the time the ash cleared, there was a gap in the sky. There is no other event in the natural world that does that. Floods pass, fires burn out, and the land returns. Earthquakes rearrange the ground, but leave the mountains standing. This removed a mountain from the world. And the people who saw it built the memory of that morning into a story so durable that it outlived every language spoken around it, every migration, every change of tools, and every change of life, and was still being told accurately when the first American soldiers rode up to the rim in the 1800s and asked what this place was. The total volume of magma erupted was something on the order of 12 cubic miles. To put a number on that, it is roughly 40 times or more the volume of the 1980 Mount St. Helens eruption. The event that we covered on this channel as the defining volcanic disaster of modern America. 40 times that, in one event. The ash went everywhere, downwind. It buried central and eastern Oregon under feet of pumice. There are places in that part of the state where the ground you walk on today is still essentially Mazama, where road cuts expose a pale layer many feet thick, and the soil above it has only had 7,000 years to develop. Further out, it has been identified across the Pacific Northwest, into Idaho and Montana, into Nevada, north into Alberta and Saskatchewan in Canada. A fingerprint spread across an area of hundreds of thousands of square miles. Traces of the eruption sulfur have even been read in ice cores from Greenland. This single Oregon mountain left a mark on the chemistry of the entire northern hemisphere. And in the valleys immediately around the peak, the pyroclastic flows did something you can still walk through today. In one canyon northeast of the caldera, the flows filled the valley with hundreds of feet of hot ash and pumice, which then cooled and welded into soft rock. Over the following thousands of years, rain and groundwater carved the deposit into hundreds of tall, thin spires standing along the canyon walls. They are called the pinnacles. Each one is a fossilized gas vent, a chimney where hot air escaped upward through the deposit while it was still cooling, hardening the material around it so that when everything softer eroded away, only the chimneys were left, a whole canyon of stone straws, each one marking the exact spot where the mountain exhaled. For the people of that landscape, this was the end of the world happening in real time. Their hunting grounds were buried, rivers were choked, the forests that fed and sheltered them were incinerated within tens of miles of the peak. Archaeologists have debated for decades how badly the eruption disrupted the human population of the region, and the honest answer is that the ash blanket makes it hard to see. But the survivors clearly stayed, and they clearly remembered, because their descendants were still describing the event accurately when Europeans arrived thousands of years later. Then came the water. The bowl left behind was a caldera, about 4,000 feet deep, and completely closed. No river flows into Crater Lake, no river flows out of it. Everything in that basin comes from rain and snow falling directly into it. And Oregon's Cascades get enormous snowfall, so the hole began to fill, and over a period estimated at a few hundred years, the water rose until it reached a level where the amount coming in from precipitation balanced the amount lost to evaporation and seepage through the rock. And there it has stayed, within a fairly narrow range, for thousands of years. The result is one of the most extraordinary bodies of water on Earth. Crater Lake is 1,943 feet deep. That is the deepest lake in the United States, and among the deepest anywhere on the planet. Because nothing flows into it, no river brings sediment, No runoff brings nutrients or silt. The water is astonishingly pure. Researchers measure clarity by lowering a white disk until it disappears. And at Crater Lake, that disk has been visible at depths of over 140 feet. In most lakes, you get 10 or 20. That is why the color is what it is. Deep, clean water absorbs every color of sunlight except blue, and sends the blue back up at you. The lake is not painted. It is simply so pure and so deep that everything except blue is swallowed. And because nothing disturbs it, strange things persist there. Floating upright in that lake and moving around it with the wind is a hemlock log. It stands vertically in the water with about 4 feet showing above the surface, waterlogged at the bottom, balanced like a buoy. Park records have tracked it since the 1890s. More than a century of a single dead tree bobbing around a volcanic crater, which tells you how little that water does to anything. Rangers call it the old man of the lake. In a normal lake, it would have rotted and sunk generations ago. In this one, nothing decays quickly, because there is barely anything living in the water to do the decaying. And now, the part that gets left out of the postcards. Look at the lake from the rim and you will see an island, a dark cone rising out of the water near the western side, shaped exactly like a small volcano, because that is exactly what it is. It is called Wizard Island, and it was built after the collapse. Once the caldera formed, the volcano kept erupting, this time from vents on the new floor of the bowl. Wizard Island is a cinder cone that grew up out of the caldera, and it stands over 700 feet above the surface of the lake today, with a crater in its own summit that you can hike to. And it is not alone. Beneath the surface there are other volcanic features, including another cone entirely underwater, and a dome of thick lava. Mapping of the lake floor has revealed a landscape of volcanic construction hidden under all that blue. The most recent eruption inside the caldera happened somewhere around 4,800 years ago. In geological terms, that is recent, not ancient history. Recent. There is more. Expeditions using submersibles in the 1980s and 90s went down to the deepest parts of the lake floor and found something scientists had argued about for years: hydrothermal activity. Pools of warmer, mineral-rich water, bacterial mats, deposits formed by fluids seeping up from below. The floor of Crater Lake is still exchanging heat and chemistry with the volcanic system underneath it. The lake is not sitting on a corpse. It is sitting on something with a pulse, which is why the United States Geological Survey does not treat Crater Lake as a scenic attraction with a geological backstory. In the National Volcano Threat Assessment, Crater Lake ranks in the very high threat category, alongside the names you would expect, because it combines a demonstrated capacity for enormous eruptions with a national park that receives large numbers of visitors and infrastructure in the region around it. It is monitored by the Cascades Volcano Observatory, the same team we met in the Mount St. Helens and Mount Rainier episodes, and it is the same team whose founding scientist died on that ridge in 1980. Now, the honest section. Because this channel does not do fake countdowns. Is Crater Lake about to erupt? No, there is no current unrest. Seismicity is low, nothing is deforming, the volcano is quiet, and it has been quiet for thousands of years. What are the realistic odds over a long span? Small, but not zero. And here is the important nuance. If Crater Lake erupts again, the overwhelmingly likely event is not another Mazama. Climactic caldera forming eruptions of that scale come after tens of thousands of years of magma accumulation, and the system emptied itself 7,700 years ago. The realistic scenario is far more like Wizard Island, a new vent on the caldera floor or the lower flanks, lava and ash from inside the bowl. But even that modest version has a complication no other Cascade volcano has. There are trillions of gallons of water sitting on top of the vent. When magma meets that much water, you do not get a gentle lava flow. You get steam explosions. Water flashing to vapor expands violently and instantly, shattering the magma and the surrounding rock into fragments and throwing them outward. Volcanologists have a word for it: phreatomagmatic, and the eruptions it produces are far more violent than the volume of magma alone would predict. It is the same reason a small eruption under a glacier is more dangerous than the same eruption on dry rock. Scientists studying the lake take this seriously, And it is one reason a small eruption there would be a bigger event than a small eruption somewhere dry. A crater with a lake in it is a volcano. With its finger on a trigger, it did not choose. So, 3 futures. The honest way to hold Crater Lake. Future 1, overwhelmingly the most likely in any year. Nothing. 2 million snowflakes fall into the bowl. The lake stays the bluest thing in North America. Visitors take the same photograph from the rim that people have been taking for a century, and the volcano beneath them stays asleep, as it has for millennia. Future 2, the middle path, over a long enough window, a genuine possibility. Renewed activity inside the caldera, a new vent. Steam explosions and ash, a closed park, national headlines, a Cascade volcano back on the front page, and a lake that changes chemistry and clarity for years afterward. Nothing that threatens a city. Everything that threatens a place. Future 3, a repeat of Mazama itself. Very unlikely on any human timescale. The system is not currently built for it, but it is the event that made everything you were looking at, and calderas across the world have refilled and gone again over long enough spans. If that ever happened, the Pacific Northwest would be dealing with something in a category America has not experienced in recorded history. Here is my honest opinion. After everything the research shows, the most valuable thing at Crater Lake is not the depth record or the clarity or even the geology. It is the story. Because for centuries, the scientific establishment treated indigenous oral history as decoration, as something to be collected and admired and then set aside before the real work of measuring rocks began. And then, over and over, in case after case, the measurements arrived and confirmed the stories. We saw it in our Cascadia episode, where the accounts of the night the sea took the villages turned out to date a magnitude 9 earthquake in the year 1700. We see it here in a story about 2 spirits in a mountain that fell inward, told for 300 generations, and correct in its essentials. Human memory, maintained deliberately, with discipline, across thousands of years, turns out to be a scientific instrument, not a perfect one. But it was recording data at Crater Lake 7,700 years before the first seismometer was ever installed in Oregon. And it got the story right. The lake is not a mystery that was solved. It is a warning that was kept. So now I want to hear from you. Have you ever stood on the rim at Crater Lake? And did anyone tell you the mountain is still active? Or did you leave thinking it was just a beautiful lake? Drop it in the comments. I read everyone. And I want to know something else. Do you think a story can survive 7,000 years intact? Or does that number seem impossible to you? Be honest. It is a genuinely strange thing to accept. If this video taught you something you had never heard, hit the like button. It genuinely helps this channel grow. And subscribe with notifications on, because next, we go 100 miles north to the mountain that stands over Portland, Oregon, a volcano with a documented eruption history far more recent than most Americans realize, watched from the windows of a city of 2.5 million people, and rated a very high threat by the same assessment we just discussed. That story is next. The ground beneath America is speaking. Make sure you are listening.